Hello, today we will be reviewing the second part of Chapter 7 and learning. And to wrap up the section on classical conditioning, in our example, even though Pavlov brought food to the dogs every day, the dogs didn't salivate at the sight of Pavlov. And so this is due to the multiple roles he was associated with, including activities that had nothing to do with food. And so this example suggests that perhaps cognitive components are involved in classical conditioning. So the Rescorla-Wagner model suggests that classical conditioning only occurs when the organism has learned to set up some type of expectation. So Spike has this expectation that you will feed him after ringing the bell. Furthermore, we know that conditioning is easier with unfamiliar stimuli rather than familiar, because familiar events already have expectations associated with them. So an additional aspect of the Rescorla-Wagner model includes the role of consciousness. So in this model, cognitive elements such as conditioning or even the expectation, are not necessarily conscious acts, which leaves an important question asking what role does conscious awareness play, and is it necessary to be aware of the conditioning process? So brain structures that are heavily involved in the conditioning process include the cerebellum, the hippocampus, and the amygdala. So the cerebellum is critical for both delay and trace conditioning. The hippocampus is important for trace conditioning, where there's a small interval of time between the presentation of the unconditioned stimuli and the conditioned stimuli. So the amygdala, which you remember plays an important role in the experience of emotion, including fear and anxiety, is especially activated in fear conditioning in humans and animals. Interestingly, rats who were conditioned to a tone and a shock demonstrated a defensive freezing reaction. So this freezing reaction is an example of the autonomic nervous system at work. So the rat's heart rate and blood pressure increased and stress hormones were released. Just at the sound of the tone, these rats were observed to have this freezing reaction, but this tone also elicited this reaction from the rat. So researchers also found that if connections linking the amygdala to the midbrain are disrupted, for example, the amygdala and the hippocampus connection is severed, the rat doesn't exhibit behavioral freezing responses. And so essentially the emotional center of the brain is unable to communicate to the midbrain in response to this conditioning. So if he heard that tone, he didn't automatically go into this freezing reaction. And with this slide, when considering the evolutionary value of classical conditioning, species must develop mechanisms by which to learn which foods to avoid. And so this is an easier way of thinking about how classical conditioning, what it actually looks like in the real world, or in our not so much real world, but in everyday life. And so learning occurs rapidly when eating in perhaps one or two trials. And so this is important because if learning took more trials than one or two, the animal or us as humans could die from eating a toxic substance. We also know that conditioning is able to take place over long intervals. So for example, toxic substances like bacteria in food often do not cause illness immediately. So humans need to form an association between which food we ate that caused this sickness or illness over a long period of time. And additionally, what we see is that humans and animals develop these aversions to the smell or the taste of food rather than us ingesting it. So this is more adaptive to identify preventable indicators that eating moldy food in the refrigerator is going to make me sick. We don't have to eat it to understand that that moldy food is going to make me sick. We see it, we smell it, and we may be able, if we didn't know, taste it before actually ingesting that and making us sick. So lastly, these types of taste aversions occur more often with novel foods than familiar foods. One example of a taste aversion that is interesting, an interesting study. So the study included patients with cancer, and they, as we know, patients with cancer often have to go through chemotherapy, and as a part of this, they often develop food aversions to the foods they ate before chemotherapy. So in order to prevent this taste aversion to, say, their favorite food, researchers started giving patients an unusual food like coconut or root beer flavored candy at the end of their meal, right before they received treatment. And what they found was that, sure enough, the aversions for their favorite foods were spared. By providing them candy, the researchers were able to condition the patients to associate the common symptoms of chemotherapy, such as nausea, to the candy and not their favorite food. And they were also able to essentially prevent a taste aversion to their favorite food. One additional explanation for taste aversions includes the evolution of humans to be equipped with this type of biological preparedness. And so biological preparedness includes a propensity for learning particular kinds of associations over others, so that some behaviors are relatively easy to condition in some species and not others. So for example, taste and smell stimuli that produce food aversions in rats do not work with most species of birds who depend on visual cues for finding food. So that wraps up classical conditioning, and now we'll move on to discussing operant conditioning. So B.F. Skinner, who we see in this picture, just this little cute old man, P.F. Skinner is credited for the development and study of operant conditioning. And operant conditioning is a type of learning in which the consequences of an organism's behavior determines whether it will be repeated in the future. So operant conditioning studies began about the same time as classical conditioning. Prior to Skinner and his history, and the history of operant conditioning, the development of this field, Edward Thorndike examined active instrumental behaviors in the 1890s, and he created this puzzle box, which we have on the slide. And this puzzle box was a wooden crate with a door that would open when a concealed lever was moved the correct way. So he studied these instrumental behaviors with cats, and these cats had to press this concealed lever to escape and or get food. And when the cats figured out by pressing the lever the door would open and they would be fed, their behavior of pressing the lever increased and was repeated over and over again when being placed in the puzzle box. So Thorndike's work differed from classical conditioning in that the behavior of the animal determined what happened next. So in Pavlov's studies, the bell and the food presentation occurred on every trial, regardless of what the animal did. Several decades after Thorndike's work, Skinner coined the term operant conditioning, or operant behavior, by which he meant the behavior of an organism produces or has some impact on their environment. So he believed that behaviors operate on the environment somehow, and the environment responds by providing events that either strengthen by reinforcing that behavior or making behaviors less likely to occur by punishing. So this is based on the idea that most organisms do not behave like Pavlov's dogs, passively waiting to receive food, but actively engaged in their environment. So Skinner also developed a variant of Thorndike's puzzle box and called it the operant chamber, which we see on this slide. This is also known as a Skinner box. So he used the Skinner box or operant chamber to study learning focused on reinforcement and punishment. And so what does that actually mean? When we look at principles of operant conditioning, these involve reinforcement, punishment, and whether these reinforcers and punishers are either positive or negative. So as these terms suggest, reinforcers serve to increase a particular behavior, whereas punishers serve to decrease this behavior. So when discussing these terms as whether they're positive or negative, positive means to add and negative means to subtract or take away. So it'll be important and helpful for you to remember when you are looking at examples in operant conditioning, you need to break down the example by either reinforcers or punishers and whether it's positive or negative. So there's two parts to the answer, whether it's reinforcing or punishing, and whether it's positive or negative. So we'll explore this further in our discussion of operant conditioning. And here are some other important things to remember, kind of key things that will help you to keep things straight, because once we start going more into operant conditioning and the other types of learning, there's a lot of, it's term heavy. So here are some other important things to remember about describing an example in operant conditioning terms. So do not confuse positive and negative with good and bad, rather than what they actually mean, which is adding something or taking something away. So think of it in mathematical terms and not good or bad. And this is easy to confuse, as you will see when we discuss operant conditioning examples. So it's just easier to, when we first present this information, to think of this positive and negative as plus or minus. So here we have an illustration of those four terms which describe operant conditioning. So in the next few slides, we will discuss each one of these four squares in the middle of this illustration. So each one of these four squares. Remember, when describing operant conditioning examples, the answer has two parts, whether it's positive or negative, and whether it's reinforced or punished. And first we'll describe reinforcement. So whether the reinforcer is positive or negative, reinforcers serve to increase the future probability of the behavior occurring again. So reinforcement in and of itself serves to increase that the probability of that behavior occurring in the future. So here we see positive reinforcement, an example of this. When we look at this first example, this is an example of reinforcement because 1, you are receiving a good grade, which is additive, aka positive, and 2, your studying behavior is being reinforced, making it likely that you'll study again in the future. Negative reinforcement, this next example, we see that you are getting rid of a headache, which is negative, so you're taking something away, and 2, following your behavior of taking medicine, the headache will go away, leading you to likely take this action again in the future, which is reinforcement. And so as you can see, I'm trying to break down each of these examples into two parts, explaining what is it that's making it positive or negative, and why is this example reinforcement. And so I'm going to say that with all of my examples from here on out to again reinforce this type of answering these questions and looking at these examples. So positive reinforcement, negative reinforcement. Here we have a positive reinforcer. So with this, if I were to give you guys a piece of candy every time you gave an answer in class, more than likely, you guys would be willing to answer more questions. So this is an example of positive reinforcement because 1, I am giving you candy, which is positive. I'm adding something. And 2, it leads students to answer questions in class. So you're more likely to answer questions because you will be receiving candy. And so that is a reinforcement. Here we have the example of the annoying seatbelt that goes off every time you're driving down the road and you forget to buckle up. So why is this an example of negative reinforcement? Let's break the example down. So first, you're taking away the annoying seatbelt alarm, which is negative. You're taking it away. And 2, you're likely to repeat the behavior of buckling up each time you get in the car to not hear that sound again, which is reinforcement. So by eliminating undesirable outcomes like the annoying seatbelt alarm, preventative behavior such as putting on your seatbelt as soon as you get in the car becomes more likely to occur again in the future. So here we talk about punishment. The first is positive punishment because we are adding something to decrease the occurrence of the behavior in the future. So we're giving or we're shouting, we're spanking in order to decrease a behavior, which is punishment. And then negative punishment, alternatively, is taking something away. So negative, taking something away to decrease the occurrence of that behavior, which is punishment. So positive punishment, negative punishment. Growing up, if me and my brother talked back to our parents, we were spanked, as is often the case. So spanking is a positive punishment because 1, you are giving a spanking, which is positive, so I'm adding something to the situation. And spanking serves the purpose of decreasing the occurrence of me and my brother talking out of turn or talking back to our parents in the future, which is punishment. So I'm giving, we see this father giving his son a spanking, and he's doing that in order to decrease the behavior of talking back or not minding what he's saying. Here we have the example, say, of a teenager bringing home a bad report card. So her parents take her privilege away of interacting on social media like Twitter for 2 weeks until she brings those grades up. So why is this negative punishment? Let's break the example down. So first, her parents took away her social media privileges, so that's negative. And secondly, they took away these privileges in order to decrease the likelihood that she would get bad grades in the future. And so this is where it's important to understand the differences between the 4 boxes on the illustration that I showed you earlier, and to not confuse positive and negative with good or bad. And that wraps up the second section of Chapter 7.